Hello and welcome. When people think of advanced material, they might not first think of steel. But steel production is not what it was 40 years ago, and market demands are changing dramatically. Increased competition, new environmental legislation, pressure to downsize components to increase efficiency, all create the need to revisit the true potential of steel. Here to discuss what is driving the steel marketplace and their own experiences and challenges as users are leading experts in engineering and engineering steel industries. Welcome to you all to this panel discussion.
Thank you. Thank you.
Now, before we get into our discussion today, I'd like to ask you, Patrick Öland, as Research and Development Director of Ovako, some of the basics of engineering steel quality, standards, and potential.
Yes, I love to do that. And I've prepared a graph here that I will illustrate this with. And I think the very most important parameter for us is really looking to the fatigue. And the question is then, how can we as a steel producer affect this? And that is by steel cleanliness. And steel cleanliness, in this case, we define as how much defect we have in the steel. So, and it's very important then about the size of the defect. The larger defect you have, the lower fatigue you can expect. And the relation is something like this. And then if you have a large defect, you will have a quite low stress that limits your fatigue. And then you will have this fatigue failure zone. And then where you want to be is, of course, below this curve, which is the safe zone. And we've done a lot of tests. We've done thousands of tests just establishing this. And we know that looking into conventional steel, we are somewhere around here. Around 100 micron sized inclusions. And that will limit the fatigue. But we also know that if you would like to have very high fatigue properties, you can go up to have this remelted steel, like a Vim bar steel. And you get up to like 1,000 megapascals up there. What we've done by making a clean steel a conventional way, we have moved from that conventional steel area up to here, where we can offer an IQ steel or the BQ steel, thus moving from that kind of stress up there. And that creates opportunities.
So we have isotropic quality and bearing quality.
Yes, so the IQ stands for isotropic quality, and we have the bearing quality.
Well, when we think of the potential that moving to cleaner steel can bring, it can be good to learn from experience. And let me first ask you then, Victor Resina, SKF is the world leader within the ball bearing industry, and SKF made a major step change through the years to using cleaner steel, right? How important was this development to your business?
It was tremendously important. I mean, it says bearing quality there, and so I mean, cleaner steel means better fatigue properties, which is very important in our products. So consistent and high quality is what we need in our products. So the bearing steel quality was developed, and as the steel got cleaner and cleaner, we could downsize the bearings, which is beneficial for our customers also.
It's no coincidence that the clean steel we call them bearing quality, so yeah. It's not a coincidence.
And SKF at that time, of course, owned Ovako, so it's actually you who were driving this development.
Yeah, and we are famous for our quality, so we need the clean steel, and also the consistency of the material properties is very important.
Okay.
And today, I could say that, I mean, failures in our bearings are very, very seldom related to the steel quality, because it's clean.
Okay, well, moving to isotropic quality steel then, one industry where that has made a real difference is the automotive industry. Dr. Maximilian Kronberger, you had a long career at Bosch and now are a very well-respected consultant and researcher. Tell us about some of the main challenges or drivers in the automotive industry and the role of isotropic quality steel?
The main driver is the environmental legislation, which started in the hard way about 20 years ago. And keeping also the driving fun for the customer, this would mean for the diesel engines to increase the pressure, the injection pressure considerably, almost threefold the old value. So this means also that with the increased pressure, we had 3 times more stress load on our parts. And at this time, we were in a veritable crisis to find materials which could withstand this high stress load. And luckily, we found Ovako as a very potential partner with a high potential steel to solve our problems. And since then, this steel is very well established in our industry for high pressure applications.
I will fill in there. I think what we learned really a lot during this project and really understood the importance of getting these properties in all directions. We have previously been working very much with sort of uniaxial problems, and now we were facing a problem where the transverse properties become the limiting, and that was an eye-opener for us as well.
Because we together we discovered that the start of a fracture is always at defects. And the larger the defect, the sooner the fracture will start. So it was logic to reduce the size and the number of defects in order to come to a higher stress load capability.
So we've heard a couple of good examples from the industry of bearing quality and isotropic quality steel in use, and we've seen that there are benefits with increased steel purity. Göran Nyström, it seems that there are many other industries that could benefit. What are your thoughts?
Well, my thoughts, when we look at this, it seems that there is a lightweight alternative to steel, and it is steel. Let me just explain. What we have seen is that with conventional steel, and for a long, long time, we are used to a performance level that ends up around, let's say, 300 megapascal. And that seemed almost like a natural law. But with the advancements of bearing quality steel, we ended up on a totally new performance level. And later on with isotropic quality steel, we moved that level up thanks to the understanding of multi-axial loading and the phenomenon of transversal strength reductions. And it seems to me then that we have brought ourselves in different steps up towards the option of vacuum remelted steel. And this is proven by experience in bearings, in diesel injection, but maybe not yet fully understood by all the industries. It really is a great opportunity to release more of the inherent strength in steel.
Well, thank you. And looking to then a future development, let's bring the discussion to another industry, to powertrain and transmission. Hans Eriksson, you have direct experience with conventional steel versus bearing quality steel. How do you see the future development of your industry in regard to cleaner steel, and how important is steel quality?
It is, of course, very important. If you look at combustion engines for cars, we can see a clear trend towards downsizing. You know, coming from V8 engines, 6-cylinder engines, 4-cylinder engines, and we'll see even further downsizing. And I would say, if you look at type of products we are developing and producing in GKN, geared systems, we can see the same trend. We have to downsize the products in order to reduce weight. We can, of course, also reduce losses in our systems. in order to support development of cars that can meet the new legislation requirements. But weight reduction is key, I would say. And when we develop systems, it's really important that we can have, of course, a good level of fatigue property in the material, but it's also very important that we can have a stable level without scatter, as it was mentioned before here. This is really important for us. And if I take an example from other processes, like machining processes, of course, working hard to reduce scatter, we need to improve CPK for all processes, and the same is, of course, also valid for the steel process. If you have a chain, some links, the weakest link is what we have to improve. And I would say that if we don't manage to get good level, stable level fatigue properties, then we need to add a high safety factor in our products when we do the design. And the safety factor, high safety factor, means that we have to dimension the products in a way that the weight will be higher. And that's not the way we want to go.
I would like to add that on a quality point of view, it's quite easy for people to say, okay, for a dimension, we make a capability. For steel, we can make capability. This is important to mention capability. And what you mentioned, Patrick, is really important. Because if we do a capability only on the mechanical properties itself, it will lead to nowhere, in fact, at the end. So for sure, we have to go into the specification a bit deeper to see what are the critical dimensions into the steel and on which dimension we have to work to increase the capability and to get really a safe product at the end.
Yes, and since steel production has developed so much over the last 2 decades only, you know, the specifications needs to follow.
Yeah, exactly.
Ludoterra, let's continue with you. You're working with the Volvo Group. Can cleaner steels play an important role for you? And I understand you already had a successful application of isotropic quality steel in marine transmissions.
Yes, indeed. We have a tougher application for marine engines, and we have so developed this solution with isotropic steel. And for me, this is a success for several reasons. The first reason is that we have managed to reach this, the need for this tougher application. So in that way, this is a success. We can say that we have increased finally the power density of the product using this solution. The second reason is that we have also been able to cope with our internal manufacturing constraint. And we have already mentioned that previously, but it was really important to be able to machine this steel. And with this project, we have shown that it was possible to do the machining of that kind of very clean steel. I don't say that it was easy, but we managed to do it. And finally, also, what is the main thing, maybe to add, this is that we were talking about remelted steel. We cannot afford in our business to use that kind of remelted steel on a, let's say, massive production. We cannot afford it. Aeronautic can, but we cannot. So let's say that at the end, it was also possible, and it was also a success because that was a solution that we can afford on an economic point of view. So it was really important to have that kind of isotropic steel into that kind of tougher applications.
I would like to add here that changing to clean steel means also looking at the technology for machining the clean steel. And originally, when we started, our technology expert were very careful to use this material because it had so low sulfur, and they were used to use sulfur for better machinability. But at the end of the day, they managed to make processes which gave even a better machinability with the new material than the old materials before.
Mm-hmm. Mm-hmm. It's not coming easily, but we need to have the teamwork with the process engineer internally to get the support from the knowledge from the steel maker in general. So it's really important, the teamwork and the way that we are leading that kind of big change, because this is a big change, this is a big step, and maybe not possible to do it in every condition. It depends on the product and on different parameters, but if we want to succeed in that kind of project, the teamwork is really necessary.
Yeah.
A lot of input, a lot of insight here today. I'd like to just end with a final question, which is, why this discussion now? Why not earlier?
Well, as I already said, we were in a fundamental crisis with our product because of the need to raise the pressure within the injection system. So our industry was a long time considered to be a very special industry with high pressure and yeah, but now the pressure goes on other parts of our business, our industry, and with the pressure to downsize components within the automobile in order to save weight and finally to save fuel. There's more need than ever to use this clean steel in other parts of the business, like transmissions or transfer cases or things like that.
Mm-hmm. And what's Ovako's role then?
Well, I think first of all, it's clear here representing both the bearing industries, transmission, trucks and cars, that we're all passionate about bringing a better solution to the market, because we all know that the carbon dioxide legislation the pressure is on. It needs to happen. It needs to be changed. Ovako's role is that we have 3 steel mills. We have 2 steel mills that produce vast quantities for automotive industries in the, let's say, the normal, more standard fashions. But we have also 1 mill that is especially capable of producing this very clean steel in large volumes. And as Ludo mentioned, I think it's an economic question in the end. You can't really go to the vacuum remelted steels. We need to bring an economic solution to the market. And there also needs to be an element of teamwork. Learning from solid experience, learning how to apply the steels. But in the end, I think I can speak for all of us, we are passionate about this. There is a strong potential here to release the inherent strength of steel.
Okay, well, thank you. It'll be exciting to see how cleaner steel will enable the industry to meet the challenges we've been discussing today, and I'd like to thank you for your time today.
Thank you.
Thank you. Thank you.